Bismillah ar-Rahman ar-Rahim. Today we will do chapter 4, part 1. That is for the exam coming up. The curved rod line in the XY plane. You can see that this curve rod line, it's a road. It is in this is the y-axis direction, and this is the x-axis direction. So it is at the floor. It is not at the z. So the z has no influence in this rod line. Okay. So the curved rod line is in the xy plane and has a radius of 3 meters. You can see that the radius is 3 meters. If a force of 80 Newton, so there is a force 80 Newton, act at its end as shown, determine the moment of this force about 0.0. So you need the moment of this force about 0.0. Express the final answer to 3 significant figures and show units. Okay. So first of all, remember for the moment around 0.0, the moment about 0.0, which is in vector format, is equal r cross f. Okay, r in vector format and f is in vector format. Okay, so let's look at r. Which r we're going to take? We're going to take either r o a toward the bottom of the tail of the force, or ROC, which is, you can see that this is the line of the action of this force. So I'll take one. I'll take the one that I have here from point O, from the point where we are taking the moment at, to point A. So let's look at ROA. So O, the coordinate of O, it is at the origin, 0, 0, 0. And A, you could see also the coordinate of A, 3 in the X. This is 3 in the X. And also 3 in the Y. So 3, 0 meter. This is the coordinate A. Okay, so we have coordinate A and we have coordinate O. So we could find the position vector OA. So the position vector OA, it is A minus O, 3I plus 3J plus 0K. So this, the whole thing is in meter, and that is the position vector. And now we need to find out the force. The force, it was given as magnitude. We need to convert this to a Cartesian vector format. So let's look at the force and let's convert it into a Cartesian format. Before we do that, we need to find out the position vector RAC, and then after that we should find out the unit vector AC, and then we should multiply it by the magnitude 80 to find out, to convert the force into a force into Cartesian format. Okay, so let's look at the point C. What is the point C? The point C, you could notice it is, let's look at the value. The value of C, it is 4 in the X, 4 in the X, and you could notice there is nothing in the Y. And the Z, it's minus 2, because it's going down below the Z, below than the Z axis. So it's minus 2, and that is C. Now we need to find out RAC, the position vector from A all the way to C. So RAC, which means C minus A. 4 minus 3, it is 1I. 0 minus 3, and that is minus 3J. And minus 2 minus 0, and that is minus 2K. And that is RAC in meters. Let's find out the magnitude of RAC, because we need to find out the unit vector of that position vector. 1 square plus 3 square plus 2 square, 4. 13, 14, square root of 14. That is 3.742 meters. And that is the magnitude of RAC. And now we should find out the unit vector of RAC. It is, this is I. It's I over 3.742 minus 3J over 3.7 I, 3.742 minus 3J over 3.742 minus 2K, 3.742. Okay. So the whole thing has no units. So now the force AC, it's 80 times minus 3J minus 2K over 3.742, and that is in Newton. So now we found the force and we found the position vector. So now we could proceed with the moment. So what is the moment of that force? The moment of that force, you should formulate the determinant I, J, K. You should put the position vector, which is from O to A. The position vector RAO, it's 3, 3, 0. And then you should put the force. Now, 80 times 1, it is 80 over 3.742. And 80 times 3, that is 80 times 3, and remember there's a minus here, so it is a minus over 3.742. And here 80 times 2 over 3.742. Remember here there is also a minus, so it's a minus here. So now we could find out the moment around that point. First of all, we do the I. So the moment, it is 3 times 80. Of course, that's going to be in the minus, times 2. Three times that, and then the 0, not going to be included because it's a 0. And then you're going to put the J, next one, minus J. 3, of course, it's going to be minus, times 80 times 2. Okay, and the other one is 0. You don't have to account for that. Plus K, which is the last one. Now here you're not going to have any zeros, so we will do it like that. 3, of course, it's going to be minus 3 times 80 times 3. 3 times 80 times 3 over 3.742 minus, and then minus 3 times 80 times 3, okay, over 3.742. And then we should use the 3 times 80 times 2 over 3.724, and that would give us minus 128i, and minus, that's going to be a plus. Well, this should be the same thing, 128j, and then minus and minus, that's going to be a minus. It's going to be 257k. This is the moment around the point O. So this is the moment of this force around the point O. Some people might find the position vector, which is very simple to take it from point O to the tail. And some people take it from O all the way to C. Whatever option you could use, you'll get the same final answer. Okay, so now this is finished. We should, something like this will come in the exam, and we should put our answers 3 significant figures. So this is, you can see that it's all 3 significant figures. It's all correct. And of course, we are showing units. These are the units shown for the moment. Let's look at the other problem. I'm trying to choose old exam problem, which is not difficult, but it's similar to the same one we have before. Okay, so now determine the moment of this force. We have a force, and this force 120 Newton going from B to point C. Determine the moment of this force about point O, and he wants to find the moment at point O, and he wants to express it as a Cartesian vector. Express the answer to 3 significant figures and show units. Okay, so let's find out first of all the moment around point O is equal R cross F. Which R are you going to take? Are you going to take OB or OC? Up to you. I'll take OB. So I'll take ROB from the point of interest until the tail of point of the force itself. And of course, the force, you can see that the force is going, the line of the action of the force going from B to C. So you need to find this into Cartesian format. We have the magnitude 120, and we have to convert it into a Cartesian format. Sometimes if he gives you the force as IJK, use it as is. But here we have to convert it to IJK. Now, what is the point O, which is the origin coordinate? What is the point B? The point B, you could notice it is 1 meter in the X. See it here, 1 meter. The Y, it is 4 meters. And the Z, it is a little bit going up. So it's 2 meters. And let's look at point C to finish it up. C is at the x-axis, and it is 1 and 4. So it's 5, 0, 0 meter. Now let's find ROB. B minus O. So I plus 4J plus 2K. That is ROP. Let's find out the force FBC. Before we find the force FBC, you need to find out the unit vector of BC. But before that, we need to find out RBC, B minus C. So RBC, C minus B, 4I minus 4J minus 2K. So this is the position vector BC, and now you need to find out the magnitude. Four square plus 4 square plus 2 square, and that's what give you 4, 16 and 16, 32, 32 and 4, that's 36, so 6 meter. So the unit vector BC, 4 over 6I minus 4 over 6J minus 2 over 6K. This has no units. The force BC is equal to force, which is 120, times 4 over 6I minus 4 over 6J minus 2 over 6K. And the units are in Newton. Okay, so now we found the force. Of course, 120 over 6, it's 20, times 4, it's 80, just 80I. 120 over 6 also, 20, times 4, it's minus 80J. 120 over 6, 20, 20 times 2, it's 40, minus 40K, and the whole thing is in Newton. So now we will do a moment around point O. Let's formulate the determinant I, J, K. The position vector, which is, we took OB, so OB is 1, 4, 2, and then you're going to put the force, 80 minus 80 minus 40, 80 minus 80 minus 40, and that would give us, if you plug it in, you could find that the moment about point O, of course you're going to have nothing in the I, 200J minus 400Q. You could just do the multiplication and the cross multiplication, and you will find out the answer like this. 200J, the I has 0, minus 400K. So this is it for